The heavier something gets, the harder it becomes to move. Eventually, every crane reaches its limit. So what happens when the load is simply too big for any crane? As buildings grew taller, bridges became longer, and industrial equipment became heavier, cranes kept getting larger to match. But eventually they ran into a problem that had nothing to do with lifting power. Some structures had simply become too large to lift at all. Not because they were impossible to raise, but because there was nowhere to place a crane big enough to do the job safely. Others were too fragile to be suspended from a few lifting points, while some projects needed to move entire bridges, buildings, or offshore platforms without taking them apart first. At that point, engineers stopped asking how to lift the load. They started asking a completely different question. What if the load never had to leave the ground? That single idea led to one of the most remarkable transport systems ever built, the Self-Propelled Modular Transporter, better known as the SPMT. Unlike a conventional trailer, an SPMT doesn't pull the load behind it. It becomes part of the load itself. Dozens of hydraulic axle lines slide underneath the structure, lifting it only a few inches off the ground while distributing thousands of tons across hundreds of independently controlled wheels. Instead of concentrating the weight in a few critical points, the entire structure is supported almost evenly from below. That approach solves one problem, but immediately creates another. Moving thousands of tons across perfectly flat concrete is difficult enough. Real construction sites are anything but flat. Even a small bump or a slight slope can twist a massive structure, introducing forces that were never part of its design. That's why every axle continuously adjusts its height while the transporter moves. The hydraulic suspension keeps the load nearly level at all times, allowing bridges, refinery modules, and entire buildings to travel across uneven ground, with movements measured in millimeters rather than inches. The modular design makes the system even more impressive. A single transporter can carry an enormous load, but when that's not enough, engineers simply connect more modules together. 2 become 4, 4 become 8. On the largest projects, dozens of transporters operate as one synchronized machine, all controlled from a single operator's console. That flexibility has completely changed how massive infrastructure is built. Instead of constructing a bridge above a busy highway, engineers can assemble it safely beside the road, then slide the entire structure into place overnight. Offshore platforms leave shipyards fully assembled, and industrial facilities receive equipment that would have been impossible to transport just a few decades ago. At first, the SPMT looks like nothing more than a platform with an unusual number of wheels. But that's exactly what makes it so clever. It doesn't try to outperform the world's biggest cranes. It solves a different problem entirely. Sometimes the smartest way to move something isn't to lift it higher. It's to never lift it at all.